Alrighty. Let's get this thing. Oops. Alrighty. Let's see. Just check the audio. Seems like it's ingesting audio, which is a very good sign. Let's get this thing started. Could be just me. Could be me plus somebody else. But either way, it's 7:30, which is the time. Let's go ahead and do this thing. We'll let whoever wants to catch up. I'm going to try out a few new things tonight, including a couple of new camera shots, which we'll see if that's worth anything. It's a really janky camera rig that's filming that part of it, so we'll see if this is worth anything, if it's interesting. I don't have a good way of showing you how janky it is, but it's really janky, but that's all right. But I actually should have the ability to more easily switch back and forth between the tabletop view and the program view and that sort of thing. So we'll just go ahead and do it. I don't expect we'll see Kenneth here tonight. He is, I think, on a train, at least if his Twitter is anything to be believed. But that's all right. We'll see who else turns up from the internet. So the project tonight is to assemble the first real assembly of my 3D printed moving light project, which I talked about a little bit on stream last time. I did some assembly of the PCB and some testing of the dimming circuit, which is brand new, which is super exciting. And this time we're going to try and assemble the whole kit and caboodle. So before we dive into actually assembling it, let me show you what the goal is here. Let's see how well this new switching system works. I go to Fusion. Then you go to Fusion. Yeah, look at that. Well, that's pretty well. The only trick here is I can't keep an eye on the stream preview and Fusion and my camera preview at the same time. So hopefully things don't wander too far off base. So this is ideally what this thing will look like when it's all assembled tonight. And it comes in a bunch of different components, which I'll try and walk through from bottom to top. So let's turn off everything. So there's this 3D printed part, which is just the base. It's got 3 standoff holders for the PCB that will slot in there, and those will take M2 threaded inserts. It's got these 2 holes in the bottom, which will take M3 threaded inserts, which will be for some kind of mounting hardware later. It's got slots for power input, a slot for the Dmx input wires. It's got a point for the wires that go to the LED and the tilt servo to come out. And then it's got a slot for the programming pins of the Arduino Pro Mini to come out as well. So that's the first component. Ooh, let's see if we can be fancy. Maybe I can show you these as we go. Yeah, I think I can. Let's see if we can get this to focus. Yeah, so that's that component, which I 3D printed in a couple of different drafts. I've really standardized on M3 hardware for most of my projects. So going to M2 with some new hardware, so I had to do a couple different drafts of this until the sizing of those M3 recesses was right. But I think that's going to be okay now. Let's go back to Fusion. Yeah, this is kind of working. So sitting down in that case, obviously, is the PCB that we looked at last time. So that will have headers on it. That will have to where the Arduino Pro Mini sits. It's got these points for DMX input and an RS-45 driver. It's got points for pan and tilt servos. It's got the LED driver circuitry, and it's got a power input point and a 5-volt regulator. But we looked at all that last stream. But I will show you that in its fully assembled form here. So there's that PCB, if we can get it to focus. Oh, I turned off autofocus. That would be why it's not focusing. Yeah, I can fix that. Let's get this to autofocus. I find the autofocus on something this far away tends to oscillate a lot, but for close-up stuff like this, yeah, there we go. So if I take the Pro Mini off of it, get to refocus. Yeah, so you can sort of see the various parts of it. I'll try and keep it in a frame here. So I'll flip it around. So this is the 3 wires for the DMX input, 2 wires for power input. Down tucked in there is the RS-485 driver. That's a Max 485. This little switch, which I talked about last time, and I'm not sure if it was incredibly clear, that is just a hard switch that disconnects the Pro Mini from incoming DMX so you can reprogram it. As you can see, it's labeled prog and enable there. And then on this side is some things that are more to do with the LED dimming. So we've got a 78M05, which is a 5-volt regulator, just for some extra power for the servos. Pan and tilt servo points. And this is one of the things I messed up on this PCB, as we talked about last time. I put these two close together and they're bridged, so I had to actually file them apart, which was super exciting. Then we've got this dimmer circuit, which is an AL8860, which we can go back into more details on later if people are interested. But it's basically a little buck converter that drives those LEDs at a constant average current. And then if there's some support circuitry around there. And then 2 pads where the LED leads will get soldered in. So that's that component. Turn autofocus back off. Yeah, you can sort of see it oscillating there. I'll turn that back off and get this refocused back down on the desk. Okay. And then we'll go back over to Fusion. So that was the PCB. We have the Arduino, obviously, which I put in there just for mostly for size sake. We've got, oh yeah, some headers. So that was another sizing thing. So the hobby servos have these little 3-pin standardized header connectors on them, sort of DuPont style connectors. I put those in to make sure this base was big enough. And then we have the rest of the moving light. So let's turn off some of these. So this is assembled from a previous project. So some of the things on here are not going to be a part of this. We'll try and make it clear as we go. So a base cover, base holder. Yeah, so I got to redo this drafting a little bit. But basically, this is what sits, this case will sit on top of that lower shell. It actually extends all the way out to these corners. And something I've done is clearly messed up the extrude in this Fusion 360 file. But that's a standard servo holder design that I use for a lot of projects. And then on top of that sits the servo itself that does the panning of the unit. That has a cover that goes over it. On top of that sits the yoke, which connects to the light. Then there's a shell piece that connects to the yoke that everything else for the light is mounted in. And inside of that actually sits the tilt servo right inside the unit proper. And then in front of that will sit the emitter. Thankfully, so this was sort of a generic emitter model that I dropped in at one point. Today we're actually going to use an emitter and a lens that sits in front of it, which thankfully fit inside this body design. So I think I didn't end up redesigning this body to fit the lensing. What I also didn't do was allow room for a heatsink. So there is a non-zero chance that we get till the end of this, I'm just going to fry my LED chip, which would be a real shame. But that's just about the size of it. All right, so let's go back to our overhead. I'm going to re-enable that autofocus, and I can show you some of those pieces before we dive in here. So let's enable autofocus. Yeah, so it'll oscillate until we get something into shot. But let's see. So we had the little base. This is that base cover and servo. So actually, I cheated a little bit. I went ahead and did assemble this base cover with a servo on it already, just to make sure it fits, because I've had some issues before with these. With the hardware that I assume comes with these is always slightly different, and that makes it a problem. So that's going to, with those tails tucked down inside, that's going to mount on top of there, just like that. And then cover is going to mount on top like so. On top of that, we'll have this little yoke. We'll put the 2 halves of the body, which would go together and make a light. We'll do another servo in there. And then we'll put our LED chip and optic inside there. Wish I knew how to make this autofocus better. Put my hand under it. Better? Not really. Well, that's all right. We'll figure it out. So that is the gist of what I aim to accomplish tonight. Let's turn that autofocus off before I lose my mind. Focus off. And we'll zoom all the way back to clear there. Okay. Great. Let's try that view. All right, so the first thing we're going to do is I'm going to apply the Heatset inserts to this little base piece here. I think for this, I'm actually going to bring it down just a little closer. We can get even closer if that's useful, but I think this will be fine for now. So first thing I'm noticing is that, you know what, I think, just a second here, I'm going to actually take you out to this view. I'm going to move my overhead camera down so you get a little bit better idea of what's going on. All right, let's see how that does. Yeah, that's better. So we're gonna start by putting the inserts into that guy. Get a little bit more light over here so we can see what we're doing. And I'm just gonna swap out my soldering iron tip. So these heatset inserts, for those who haven't used them before, are really easy to install with a regular soldering iron. You can buy the couple $100 worth of tool from McMaster that you're supposed to use, but honestly doing it with a conical tip and a soldering iron is just as easy. So I've got my fine point tip there. Turn my iron on, and I like to set this to, this is a PLA part, I like to set it for about 500 degrees Fahrenheit for PLA. Now, I don't know what the recommended temperature is for ABS, or honestly, like if you use the official tool, what they recommend you use, but I think 500 degrees Fahrenheit on a soldering iron tip does just about right. Put that in there. Here, I'm going to bring some of these things in the frame so you can tell what's going on. Get that a little wet. Move this guy out of the way. I'm going to get out my handy dandy bin O M2, M3, and M4 inserts. So this is just an Amazon case. I think this whole thing was 20 bucks. And it has inserts of M2, M3, and M4 size in various lengths. And this is all I plan to ever need. So that should be easy enough. So I'm going to start with these little M2 by 3mm inserts here. Let's get out 1, 2, 3, 4, 5, 6, 7 of those. My iron has come up to temp, and I'm actually going to put this in my vise. I'm going to peel off the brim from this printing here. So I don't really need to do a brim on something this large, but for a long time my printer was miscalibrated, and I didn't realize it, so I'm just sort of used to using a brim on all of my large-scale prints now. But that's all right. This vise is also 3D printed, of course. This is a design that's just on Thingiverse somewhere. Right. I will have to be a little careful not to melt the vise when I do this as well. Now let's see, how in focus are we now? We're a little closer. Not bad. Before we go on too far, I'm just gonna try and get this a little bit more in focus. Ooh, that's worse. That's better. All right, we'll live with that. Let me apply that so it stays. And let's start soldering these things together. Alrighty, so like I said, these heatset inserts are pretty easy to use. For the M2 ones, I like to use my pair of just fine tweezers here. I put the part roughly in place. Heat it up and melt it down into the object there. Now there are some who would encourage you to, basically once you have it most of the way melted in, you pull it out, you turn it over, and you just sort of mash it flat, and that does help get it level. That's a little bit overkill for these. I honestly don't know that I'm going to need all 4 of these just to hold the lid in place, but it's just a useful tip if you need something that really does need to be flush to your top surface or your bottom surface, say. And I will probably end up doing something like that on the mounting points for the PCB down in there. Oops, you can't see that at all. So get down in there, melt, 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 and done. So that's those 2. And I think, honestly, I might just do those 2 for now and see how it stays, and I can always come back and put the other 2 in later. One trick about doing the little heatset inserts here, where there isn't a relief hole in the bottom, is the holes for these, I know it looks like it's capped on top, but the holes for these are actually fairly deep, so the spoil you get when you're melting in with that soldering iron has somewhere to go. Otherwise, it just comes right back up through the hole, and then you don't have anywhere to put your screw in. So I think we'll call that good for now. Let's release this. And I'm going to do, down in there, those 3 more M2 mounting points are for the PCB. So I'm going to put the heatset inserts into those now as well, as long as we're right here. Try and find a place to put a light that you can actually see what's happening, but that's part of the problem of working with black PLA, is I don't know that it's taking to camera very well, but that's all right. What if I do... Well, if I just use my third hand to hold a light there, it would be great, but for now, I think we'll live with that. All right, so same as the first time. I'm going to take my heatset insert here in my little tweezers. I'm going to poke it with my conical tip, and I'm just going to guide that right down into the hole. Let that melt, 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 melt. And when it's fairly in there, just release. And that's all there is to it. The conical tip, you can use a chisel tip if all you have is a chisel tip. I find that the conical tip releases a lot easier. When I use the chisel tip, especially with the M3 size ones, it often gets stuck, and then you end up pulling the inset right back out, but you've already sort of ruined your plastic on the inside, so that's not ideal. We'll do 2 more of those. And for those who are just popping in, so this is going to be the bottom case of my little 3D printed moving light. I don't know how easy it is to tell scale from just an overhead view, but this thing is about maybe 1.5 inches square. So I'm hoping this thing turns out adorable. All right, we'll do 1 more heatset insert here. And again, probably not the greatest camera angle to view, but you can tell it's taking maybe 3 or 4 seconds to melt this down in. With it up at 750 Fahrenheit, which is what I usually solder at, that would take maybe a second. So it's nice to turn the temperature down just to give yourself a little bit more time to get things right. So that's our 3 inserts down in there. I'm going to do my M3 inserts for future mounting hardware. I don't know what the mounting is going to be, but those are exactly on 1-inch centers now. So if I had some like 1-inch box truss, I could come up with some kind of mount to hang this from, which might be kind of fun. So we'll get out our big box of heatset inserts one more time. So that was M2. So we'll do M3 by 3 millimeters by 5 millimeters. That'll be fine. I have this dream of someday making a bunch of these and then printing some 1-inch square box truss and hanging them off of that and having my own little disco party rave. Maybe with like a tiny adorable chain motor would be fun. All right, so same thing. We're just gonna let that heat and melt right down in there. This bigger M3 ones, I'm having just a little bit slower of a time getting them in, but I am gonna do, so I'm gonna pause right there. And I'm just gonna let the force of my hand make that flush and square against the bottom. That's sort of the easiest way I've found of making sure that those end up flush. All right, so we'll just do that a little bit loosely this time. This is a little bit easier to pull out. Do 1 more insert. Oops. A little too loosely. I hope everyone can hear me out there. Like I said very early in the video, I'm trying a new audio setup tonight because the shotgun style mic that I have been using is now for some reason making a lot of noise, like as if it was electrical hum, but I can't figure out where it's coming from. So I'm using a lav for the first time, and I just hope it sounds decent. It did in testing, but I'm just gonna trust that if it wasn't, someone would say something. All right, so that's my heatset inserts. 5 in the top, 2 in the bottom. I've already soldered the wires and headers to this little guy, so I don't need to worry about that. I'm just trying to remember if there's anything else I need to do to this before I install it. I need to solder on wires that will go to my LED. That's what I need to do. So let me grab a bit of wire. So I'm going to use some of this stuff, which is that true? Let's go a little thicker. I'm going to use, that's 24 gauge. That should be all right. Oh, let's see, do I have anything a little thicker? I'm just pouring through my wire section up here. 26 gauge. What are you? You are 22 gauge. A little fugly and a little inflexible. I think I'm going to go with this 24 gauge brown multi-strand stuff. Partly because 24 gauge will be fine for our purposes today, and partly because it's the most flexible that I've got. I'm going to cut off far too much of it. And then we'll just have plenty for whatever we need to do. So there's that. You can go back into storage there. And we'll solder that to the two pads just here. That will be where the LED will ultimately connect. Let's strip those back a little bit first. Now, obviously, this is not going to be quite a long-term solution, right? Because 24 gauge for half an amp, I might be okay continuous. What I really would like is to get some nice black, multi-strand, flexible wiring. It can sort of be a longer-term solution. Let's see. So for what I'm doing next, I'm not going to bother swapping to my chisel tip, which I have normally used for a soldering job like this. I think I'll be okay just using this conical guide that I've got installed. So that's one. Sort of twisting those strands back together so they go through this through hole just a little bit easier. And then once they're through, just kind of bend them over, and that helps them sort of stay in place while you're soldering. All right, so that's those. We'll shove that in there. Grab my solder. This is also maybe like the most useful 3D printed thing I have in my shop. It's just a solder holder. I know you can buy them, but like I sat with my soldering, my roll of solder on my desk for the first 10 years of using a soldering iron, and now I have a holder and I just can't go back. So because I don't have a chisel tip in here, I'm just going to lay that conical tip right across that pad, and that's going to hopefully help a little. Oh, you know what I should also do? Turn my heat back up. I still had it set at 500 from doing those Heatset inserts. So that's back up at 750 Fahrenheit. I'm just going to give it just a second to come back up to temp. There we go. That's what I want to see. Just melt and flow. The other one, melt and flow. Easy. And take my flush cutters and just trim off some of that excess wire so nothing shorts. The driver chip that I'm using, the AL8860, does have short circuit protection. If the LED string short circuits, it just stops oscillating. It basically shuts down until the short clears, which is super handy. All right, so that's the LED wires. Is there anything else I have to do to this guy before I put him in a box? I think the only thing I might do, there's one capacitor missing. Now that I've just able to autofocus, I don't know if you can see it. There's a little tiny set of pads right by this regulator right in front here called C5 that I didn't populate earlier. And I was having some issues with oscillations on the voltage regulator. And the only reason I think I might do it now is because if I don't do it and I should have done it, it's going to be basically undoing everything I'm about to do to make it happen. So let's just do one last little component here while we're in a position to do so. So, get out the big box of stuff. These are my standard Menards storage bins. They're like $1.19 a piece. And I have maybe 60 of them now. They're not, if I was going to go back and standardize on a bin a second time, I don't know that I would choose these, but the fact that everything's in one bin is super useful. Here we go, 10 microfarads, 35 volt X5R. That's what I want. Okay, so bring this guy back over. And we'll pull out. So this is just a little 10 microfarad cap that's going to go right next to this voltage regulator. And we talked about this in the last stream, but the voltage regulator is really just there to provide extra power to the servos. The voltage regulator, there is a voltage regulator, of course, that'll be on the Pro Mini, but that's rated for like 150 milliamps or something like that. And the servos have a holding current of, several hundred milliamps. So what I was observing as I was doing a little preliminary testing on this board is if you run them both at full speed at the same time, you can get brownouts on your regulator. So hopefully, and that's even with this external regulator, so hopefully the cap helps. It certainly can't hurt. Yeah, it's not as inexpensive as I would have liked this cap, and it's going to be kind of a pain to get in here now that I've put this regulator in place. But that should be okay. I'm going to reach in there with my iron. So this is kind of the cheating way of doing SMDs by hand, is to tin one pad, then grab your part, go in and solder it to that pad, and then go and flow the second pad once it's already held in place by solder. And the trick is going to be, how do I do that with only two hands? I should have done the other pad, is what I'm seeing. I guess I'll tin both of them, and then I'm going to have to flow this a couple of times. So I'm going to get in there with that little tiny, this is an 0603 size part. It's like the size of half of a grain of sand, maybe 1 grain of sand. And it's about as small as I care to comfortably solder. I have done smaller by hand. It's just not super fun. So for a project where miniaturization is not that critical, I will go to 0603. I will also usually do this, try and go parts from small to big, because right now this regulator is absolutely getting in my way. And I don't know if I'm going to be able to fix this. Well, let's give it one more pass, and if it doesn't go, then we'll just move along. Try coming in, sort of sneak up underneath it, as it were. I should say, I don't know who is or will be watching out there, or what part of the world you're from. These are 0603 Imperial, not metric. Because there's one of each, and they're different. Of course they are. Okay, so that, I think, is soldered in place. It looks fine. Well, it looks awful, but I think it will be fine. So let's get that out of the way. We'll get this back over here. We'll do a little personal camera work. And we'll get this puppy mounted. So on this particular mount, we can come in even a little bit. Oops. I can either pull my camera off the shelf, or we can come a little closer. Go. Move the soldering iron out of the way. I'm actually going to turn the soldering iron off for a little bit. So I'm going to take my existing wiring. I'm going to thread my 3-wire DMX and my 2 wires for power out their respective holes. And then these LED wires are ultimately going to fit right out that top slot there. Ooh, looks like I need to get that voltage regulator seated a little bit better, which is going to be kind of fun. If that's the case, we'll do just a little bit more work on the soldering before we start to assemble. So I am going to cool this off, and for that amount of rework, I am going to switch to a chisel tip. So just because this is still hot, I'm going to use my pliers just to loosen this ring. That'll come right off. Tip comes right out. I'm going to grab my conical tip, which I just leave down in the holder here. Ooh, come on. There we go. It's like Operation. That comes out. That goes back on. And you're probably supposed to like calibrate these tips when you swap them. There is a calibrate function on the soldering iron's base station, but honestly, it's always worked out fine for me, so I just leave them. I mean, if I was using a fancy like Metcal soldering iron, I would probably do something a little bit more precise, but for my purposes, this is plenty. So I am going to, oh, that's right. I'm going to just put the other tip back in there. Grab this guy one more time. So the problem I'm encountering is that voltage regulator fits inside the case when the bottom of it is actually flush to the PCB, like it should be, but I got a little lazy about it and it's not. So I'm gonna need to do a little work there. I'm just gonna clamp that in the vise. I am going to probably use this guy. I'm gonna turn the iron back on. Come a little closer. So this tab is directly connected to one of these pins, so it is going to get hot as I start to work with this solder, but that's okay, because that's what I have tweezers for. I'm actually going to pre-tin this just a little bit. This is a little cheater's method. If your iron is not conducting heat as well as it should be, you can put just a little bit of solder on the tip, and that'll help the heat conduct into what you're soldering. The other thing I could do for today, just to get this thing moving along, is just to bend that tab over, because I'm not going to run this thing at a particularly high voltage. So given that that is well and truly stuck, that might be my solution. All right. So we'll just make sure that that's cooled. And I will just, for today, gently. Ooh, that's not going to do it. Maybe I can just lean it over. That might do. Well, if I get into trouble there, I'll have to come back and fix it later. But I think for now, I'm just eager to move along, because I'd really like to see this thing like moving and twitching by the end of the day. Let's bring it back up a little bit. So we were putting the power wires in, putting the Dmx wires in. Yeah, I think that's gonna be okay. I have to kind of bend it out of the way of the LED wiring there, but I think we're gonna get away with that a little bit. And next time I just won't be so lazy when I solder it all together. All right, so next step is to attach PCB to the base, and I have, once again, a little hardware kit. So these are some little M2 by 4mm screws that'll go right into those heatset inserts we used earlier. And these actually take a little tiny 1mm Allen head drive, which I thankfully happen to have one of. I think from a kit I got as a birthday present once. One of these, one of these do-it-all electronics kits. But it came in really handy. So, trick is to not let it fall off the bit as we assemble. Once again, I'm going to use these tweezers to get it down in there. And then we'll just make sure that it's going into that insert. Ooh. Oh, I've lost my bit here. I'll screw that back on. For some reason that one is not wanting to thread. Let's try a different one to start with. Retighten this bit one more time. All right, so that's tight. And that's tight. Let's try this lower one here. Yeah, that one worked just fine. Why didn't the other one work just fine? All right. Well, that's easy. I'm going to leave that a little bit loose, and we'll come back and tighten it when they're all in place. This one in the corner is not so easy. So I went through actually a couple of different designs for this case, trying to find a way to basically make it a base and walls and a lid for exactly this reason, because doing any kind of assembly down inside here is kind of a pain. But then you would need additional fasteners to sort of secure that wall piece on. And that just didn't seem, at some point there's diminishing returns, right? It's easier to screw this on, but then you've got to screw an additional piece on. Not that this is exactly easy. Here, I'll tell you what we'll do. Get that in the tweezers, get it down in the hole, find our insert, and thread. Okay, I'm actually going to go ahead and swap this out for a slightly stouter bit. There we go. That'll just help prevent that slipping problem that I'm having. All right, that's staying all right. Let's try this one. So once again, we'll grab that with the tweezers. Oops. Back. Grab that with the tweezers, get the driver into it. This is a screw installation on the internet. All right, that's in all right. I can feel at the bottom of these holes there's a little bit of that spoil that's coming back up, that the plastic has actually come back up into the heatset insert a little bit there. That's preventing me from screwing these all the way down, which for the sake of a demo will be fine. But it's just like another thing to add to the list of things to fix for the next revision of this. Let's come in this way. That list currently includes, obviously, don't bridge your pan and tilt servo pads together, as well as pick a stouter 5-volt regulator. That's probably about it. I guess for now, we'll see how we do. And maybe pick some more sensible locations for those mounting holes. But that's those 3 screws in, finally. Wasn't that exciting? Let's move on to, let's drop an Arduino in it, which will be good. And I'm actually gonna, I think I can program this once this thing is sealed up. At least that was the intention. So I should be able to just drop this in. It'll be a little tough. So that little slide switch down in the bottom there is meant to switch between program and enable. And it won't receive DMX if it's in program mode. Let's see, can I get to that switch once the Arduino is in. If not, I should have put another hole. I might be able to. Let's see. Let me grab a little flathead screwdriver here. Oh, I can definitely touch it. I just can't see what I'm doing. So in that case, let's yeah, we'll just have to pull the, that's in program now. Can I get it back to enable? Yes. All right, so that'll be my method of getting it from program to enable when it's closed. I'll just stick a screwdriver in there. So that's another thing for the list, is I'll need another hole in the side of this case. All right, let us carry on. Let's put the top plate on, and I think that top plate should go like this. So this is actually kind of a critical step, because this is going to define ultimately where in relation to this base the yoke sits. So I think I want my tails coming out here, and I want my yoke coming off here. So this, before I seal this up, this has to get poked down inside here. So that's just a standard 3-pin. Let's plug that into the pan connector. And then all of this junk has to get buried down inside this case for now. And then, yeah, so I had been imagining it going like that, actually, which is with the servo more leaning toward the connector side, which I think is okay. I think we can roll with that. All right, so now time for more screws. I'll make sure those LED wires are poking out the side there. That's how we'll actually get power to the LED later on. And yeah, these clearance holes are just a little. Oh no, that's not bad. I had a little bit of stringing going on in those holes, but I think I've punched through them okay. These just don't feel like they want to thread particularly much. I'm gonna have to go to a shorter screw length, I think. Yeah, let's do that. So we'll go to M2 by 4 millimeters instead of 6. Okay, so put the screw just there. What I think I'm also learning is I should use some deeper of those M2 threaded inserts, so that if I do get spoil, it's I can still use a relatively long screw and get the seal that I need. Alrighty. Yeah, there's that one spoiled too. That's all right. That's not going anywhere. All right, so that's our pan servo. That's a good sign. And it looks like I can still program that little guy, which is the whole idea of this hole. Yeah, that's quite good. Oop. I don't know if you could hear that move a little bit there. So this Arduino still has a program on it from when I was testing a little bit of my programming last night. So that's a good sign. So what's next? Next is the cover for this. And this is actually a known issue. I don't have a great way of securing this cover to this servo, but that's okay. For today, it's just sort of press fit around there. That'll ultimately need some kind of mechanical fitting. Oops, I pinned my LED wires. Let's free those up and just tighten this down a little bit more. And this one too. Yeah, you can see as I'm working on it, that servo cover kind of fiddling around a little bit. I'm going to live with that for today for the sake of getting this to a test sake, but at some point I'm going to have to find a way to secure that in place. Let's see here. that help us see anything? A little bit. A little bit it does. Just trying to keep an eye on the picture and make sure you actually see black things that I'm working on. All right, so next is the yoke, which will connect the body here to the pan servo. Let's go back up to this solution, which I think was better for lighting. All right, so this placement will also end up being somewhat critical, and thankfully I can adjust it after the fact. Although maybe I'll run a test program and we'll see if we can calibrate it in advance. So, right, quick review, Hobby Servo has about 180 degrees of rotation, right? So, and there's not a good way of telling just from looking at this visible gear what orientation it's in, but where I mount this arm is going to define probably one end of the total rotation, the total pan of this unit. So what I'd like to do is actually pan this entirely in one direction and then attach this, and then that will sort of be locked in place. So why don't we do this in 2 steps? Why don't I affix this this pan servo, this yoke here, and that is done just with a little tiny Phillips head screw. I'll just do lightly for now. Yeah, and then that may actually be the calibration that I want. So you can see if you look down at it there, you have actually a little bit of over travel before you actually hit a hard limit, but you only get about 180, 170 degrees of actual usefulness out of it. But that's okay. So I think if I do it in this orientation, and that really is its travel, I think this may actually be okay. So I might just press on, and we'll skip our calibration step for now. So, because I can also always come back and loosen that screw if I need to. Maybe I will just tighten it up a little bit for now. Doing screwdrivery things on camera makes me appreciate Big Clive and his taking things apart. Trying to hold a screwdriver without getting in the way of something is more of a challenge than I would have thought. All right, so next is the body, and this is the point when it's going to start looking like a moving light. So the body comes in 2 parts in my design. You have this part, which holds the servo and the LED star will mount to the front of that, and then this part is basically just a cover. It's just cosmetic. So the first thing we'll do is actually attach a servo to the inside of this body. So that is going to go down into the body like that and sort of poke out the side, and I'll mount that in place there. So let me grab... Ooh, you know what step I've missed? So I've got this pan servo. It's got this bit of wiring that's got to get to the control box in here. So I'm going to have to, at some point, pop that top cover back off and get that wiring in. The whole extra space in this notch there is meant for exactly that purpose, and I've just forgotten. But that's okay. So I'm not going to make the same mistake here. I'm going to thread this servo connector out through this hole before I start to screw it in place. I remember this from the last time I tried this design, which was some time ago. It's not entirely trivial, but it does fit. Ooh, come on. Come on. There you go. All right, so now we're going to screw that servo to the sticking place, as it were. Just dump out. All of the servos come with this sort of standard kit of parts, right? You have your arms for your remote-controlled plane or whatever you're going to use it for, and I'm not going to use any of those, but I am going to use these 2 little mounting screws. And there are 3D printed into this design a couple of little holes, sort of pilot holes inside the body here, but I'm also going to have to sort of screw into the PLA itself, and that's just what it is. And that's what they're designed to do. Like, these screws are meant to, you know, tap themselves into plastic. So it's not like I'm actually abusing anything here. It's just not quite as smooth a mechanical design as screwing something into a thread. Actually, oh, no. I was going to say that went pretty well, but I wasn't actually screwing into anything. I was just screwing into the servo. Get that nice and flat. Let's see, what would be better here? Is that any better? A little bit, because now I can kind of keep my hand out of the way. I don't know who's out there in the universe tonight, but I am probably 90% building things and 10% being on video. Maybe not even. Maybe 95% building things and 10% being on video. So if it feels like I'm making things up as I go along, that's exactly what's happening. All right, same thing on the other side. Just get that screw right down to the PLA there. Let's see if that's happening. All right, so now that's going to be my tilt servo, and you can see that little mount coming right out the side there. And I probably should have left those screws just a little bit looser so it'd be easier to mount to this yoke, but that'll be okay. So, speaking of, let's get the yoke back in here. Back up a little bit. Now, much like the base, that collar there and that servo nub are going to mount to each other with another one of these itty-bitty mounting screws. Yeah, just cinch that right up. Yeah, now we're starting to look like something. So I have my tilt. It's a little bit loose, which is okay. Snug that up there a little bit. Because this, we should hear the servo run there, and I'm not quite. It means the plastic is not making a great contact. Oops, that's all right. So then, this is actually... you know what? This is backward. This is the right-hand side, which is not an issue. It just means I am going to have to do that yoke calibration after all. So I'm going to swing. Well, maybe not. Maybe we can still get away without it. Yeah. So we'll be fine. And the way I can tell it's the underside is I want this little tail that's going to be the servo wires, and it's ultimately going to be the LED wiring as well. I want that poking out the underside of the head of this unit. Let's see if that'll snug up a little better. Yep, and we snip that in place. I have to munge one of the little mounting tabs a little bit. But you can see we're really starting to look like a little tiny moving light. How cool is that? So what remains? So the LED chip obviously has to go in, and we have to get this servo wiring back down into that base there. And then we got to give it some programming, and then we should be ready to fire it up and give it a test. So we're getting awfully close, which is exciting after, watching how you do screwdrivers on camera. So let's see. Of those things, let's do the easy ones first. Let us get this servo wiring down to that base. Undo that screw. Undo that screw. Yeah. This screw mounting method, I think I probably should have done all four, because this one is not gripping as well as I would like. But again, just for the sake of a demo, I think we'll be okay. The sad part is, doing all this demo and saying things like, oh, all I have to do is X, or all I have to do is Y. There's a non-zero chance that they get to all the end of this and something just straight up doesn't work. But that's kind of the joy of doing this whole thing on stream. All right, so I'm gonna make sure that those LED wires and those servo wires both make it out through that little gap in the case there. And then we will button this back up. Let's go back to our angle cam. Let me, real quick, what happens if I spin you around? Does that look like anything? Well, that's not bad. Maybe. I don't know. I'm just trying things. All right. Yeah, that threaded insert is pretty spoiled at this point. But that'll hold. So that'll be okay. Great. So now what? Now, let me take you back to, oops, back upside down again. Let me spin you around here. Yeah. Ooh, let's get that really tightened back down in there. I might also need to check that these M2 inserts are actually, and the nuts, frankly, are to spec, because they don't seem to be threading very well. But that's all right. Okay, so we got the servo wires in that I forgot the first time, so that's a very good sign. Now we need to get the LED soldered, get this thing put back together, and get it programmed. So let's get the LED soldered. So to do that, here, at the risk of undoing all our good work, I'm gonna flip us back around. Try and estimate the required wire length for these LEDs. Be about like that. We'll trim them short here. So this LED star, and I think I talked about this last time as well, but this LED star is 3 400 Kelvin neutral white LEDs. 3 neutral white LEDs in series. So they have a forward voltage of something like, 9 to 10 volts. I think nominal is like 8 point something, but I'm finding that to really turn on efficiently, that's like 9.5, 10 volts. And I'm just taking one more peek down inside here to figure out which of these two wires is going to be positive and negative. And to do that, I don't think I labeled it on the board. I'm going to take myself over and just check the schematic one more time. So let's come in here. If I switch to the board view, do you get the board view? No. I have to do that manually. Let's do that then. Yeah, there we go. So I'm going to come into the schematic here, and I happen to know that the side with the inductor is the anode. So that's the outer pad there. That should be fine. All right, so let's, oops, yes. Let's go back to tabletop there and have a look at that. So that means this wire should be on the positive side of things, and I could probably flag that in some way while I'm here. Just get a little bit of tape. So this will be the LED star that we're using today. So like I say, that's 3 neutral white LEDs in series, and they're jumped together by those adorable little 0 ohm resistors there. And then this is an optic from a company called Carclo. Both of these are from LEDsupply.com. They're pretty cheap and they came pretty fast. This is actually a clearance item. It was like $6. And I chose that partially because I figured there's a not zero chance that I fry a chip or two in the testing of things. So if I was going to fry something anyway, I figured it might as well be something that was relatively inexpensive. Although the full price ones are still like $7 or $8. So it's not like it's a massive savings, but you know, I figured if I'd be less sad if I fried a clearance item rather than a full price LED star. We'll just let's clean up a little bit as the soldering iron comes back to temp. All right, so I'm just gonna, these wires are left over here from a previous test, so we're just gonna take those off just briefly here. This is another moment when that trick I talked about, which is tinning your iron, can help quite a bit. Just tin that a little bit. There we go. That lifts off. That lifts off. And then we'll take the 2 wires coming out of our buck converter circuit and run them directly onto this chip. I've stripped these wires back just a little long. Trim that. And trim that. And here's another way to cheat if you're soldering wires to a surface. This is not a good thing to do, but I'm going to pre-tin the wires. And what I should do is use a little bit of flux, but I think we'll be okay. Basically just heat those up and touch. And same on the negative side, heat those up and touch. And there we go. So that's soldered together. So that is ready to go into our moving light. I can screw this back together, hopefully for the final time, although I thought the first time was the final time, so I think I'm just wrong. I also think that this bit is not really a 1mm bit, because it's partially just spinning in these screws. Okay, so now got my LED soldered on. Oh no, you know what I've done? That was just supposed to go through the hole in the back of that moving light first. This whole project is like order of operations, the construction project. So we'll desolder those. We'll thread them through the hole. And then we'll resolder them. Also, future Jeff, when you're watching this, if you ever make another version of this, it would be easier to thread these through before the servo was installed. But that's not your problem, future Jeff. That's current Jeff's problem. All right, so those are now threaded through the hole in the back of that light, and now they're ready to be soldered onto this LED. So once again, we'll take our positive. I feel this sort of sense of impending progress, but if this thing doesn't work, or it only works partially, there'll be quite a bit of troubleshooting that we'll get to do, which also will be kind of fun. But, you know, not quite to the breath-holding stage of this project yet. So there's that. Let's see, with the optic... Oops. Move my wire so I can get the optic down in there. There we go. That just snaps into place. Move those around a little so you can see a little better. Yeah, so that optic just snaps into the 3 holes on that LED star there. And then for the moment, we'll just sort of loosely place both of those into the front of this. Huh? Check that out. Isn't that sexy? So we'll do that. This usually is a snap fit, but I've broken off a little piece of it here. So for today, it's going to be a gaff tape fit. This is partly why I advertise this as first assembly and not final assembly, because there's going to be just a few times when these things happen. I'm going to tape this closed. We're going to write a little Arduino code, and we're going to fire this thing up. In fact, I think this one's ultimately going to be programmed how we want it already, but we're just going to double check it before we send it into motion. So there we have our little tiny adorable moving light. We don't know yet if it works, but we have it assembled. That's pretty cool. And that's freaking adorable. Here, let me zoom you out so you get a little sense of scale. It's cute. It's super cute. Look how cute it is. That's awesome. Now, if it works, it'll be even cuter. So we're going to go over to the computer. I'll take you over there with me. We'll do a little programming. Make sure this has the code on it that we want. We're going to program up our transmitter and make sure it has the code on it that we want. And then we'll get to play with this thing a little bit and see if it does the business. So let's head over to writing some code. Let's see if this works. Let's transfer over to, yeah. Alrighty. Let me solve an audio issue here. And we'll roll up. So we're just going to write a little bit of Arduino code here, and then we'll be ready to push it into that moving light we just finished building, and then we'll be ready to test. So I think this is all going to be essentially good. So this is my Dmx slave test code here, and it's really dead simple. It just tells the Arduino which pin the LED is tied into, the pan servo, the tilt servo. We define a couple of servos. Oh, why are you not? Ah, you're looking at the other screen. I'm so sorry. Here, let me double check. You want to be on slave test. That what we're looking at together? Yeah, there we go. So here we are. So we define the LED is... Oh, that LED is actually going to change. So this is the onboard LED, of course, that I was using for testing, but we want to use the pin that's connected to the... There we go. We want to use the pin that's connected to the high power LED that's coming out the front. Or rather, the driver for that will take PWM and do dimming with it. So let's take a look back one more time at our schematic. Oops. At our schematic. And we will see what pin we chose to use to wire up. So I think it looks like it's D3 here, which is coming out. It's going up and under. Let's turn on our bottom layer. Yes, and that's connected to our control pin here. So that's a good sign. So I'll take you back over to the Arduino code. So we actually want to change this from 13 to 3. We'll just double check everything else. We define our two servos. We enable Dmx slave mode. We set the LED pin, which is now 3, as an output. Let's just right off the top here, let's set it to 0 so it's off when we start, and we attach our two servos, and then the loop should be really simple. This is all left over. So this down here I believe is correct. So we're gonna get two Dmx values in addresses 2 and 3. Those, like all Dmx values, will lie between 0 and 255. We'll map them to degrees for the servo, and we'll send those to the pan and tilt servo. We're also going to need to modify the LED code. So that will end up being a PWM, which on the Arduino code is analog write, to the LED pin, and that will be the value of channel 1. If you do end up writing your own code for this, it's important to know, so this is channels 1, 2, and 3 with relation to your start address. So if I change this start address to 10, this is now really Dmx addresses 11, 12, 13 instead of 1, 2, 3. But I'm just going to leave it at 1. So we basically have a 3-address Dmx device here that's going to be address 1 is intensity, address 2 is pan, address 3 is tilt. So that looks correct. Let's just double check that I have a COM port open. Yes. I'm going to over here. Nice thing. I think this is going to work out just fine. I'm going to plug in. This guy may start moving when I plug him in. Ooh, it's thinking about it. Yeah. I am gonna real quick re-enable autofocus over there because it seems to be confused. And we will upload our slave test program. Oops, I've got a little error over here. Let me bring you back over so you can see what's happening. A little error, get channel value, Dmx slave O dot get channel value. Just a little typo. We'll upload. Compiling sketch. Uploading. I can see our little FTDI converter there flashing. And that's good. And it's getting no DMX, so it's confused right now, so it's probably why it is currently tilted hard down as much as it can be. But that is the code that ultimately that will need. I'm going to unplug that for now. And roll back over there. I will also need to write just a little bit of code for a controller. And for that, I could use a light board. Like I could have brought home a Nomad key or, plug this into an EOS or like whatever. But I'm actually going to use this little adorable guy. This was an earlier generation of this project that I think is actually really good as a standalone project. This is basically just the DMX receive and transmit portions of the moving light shield. So it's essentially, it's a DMX shield for an Arduino Pro Mini. So with that shield, which was dead simple to make, and an Arduino, now I have a device that's just that big that can receive or transmit DMX, which is super exciting. So what I'm going to do is make it transmit DMX. And I'm just going to write a little bit of a program to run, let's do pan back and forth, we'll do tilt back and forth, and then we'll do intensity from 0 to full and back again. And that'll be our test program. And then if we want to get fancy about it and we have a little more time this evening, maybe we'll write something that can like read from a potentiometer and set the parameters that way. But we'll see how well we do on our first pass. I also think there's a pretty good chance that that this tilt servo is not where I want it to be. But that'll be a troubleshooting step that we get to after we get it programmed. So while we're still over here, I am going to plug in the transmitter portion. And you have to pay attention to the LED that's sticking out the top here. That was from a testing phase when I was using the same device, although I guess I could use it now. So let's roll back over to the Arduino code here, and we will open up, I'm going to change over to the master code that I wrote earlier. So this was part of my test earlier. So, really similar idea to the slave code. I'm going to send... Let's see, a lot of the comments you need to pay attention to, they're left over from a demo code from the library. Be 3 DMX channels. I'm going to define an int called dimmer value, an int called pan value, and an int called tilt value. Just there. I'm going to define a DMX master device called DMX master. And I actually prefer to do camel case for all of my... object names, so I'm just going to do a little quick find replace. There we go. Replace all. Okay, so in our setup here, we're going to enable our master. We're going to set, yes, so on the, actually on both devices, on the DMX, on the Pro Mini, the Arduino Pro Mini DMX shield, and on the moving light shield, I've hooked up the pins on the Max 485 that allow you to control whether it's being a transmitter or a receiver. In fact, I can probably show you that. Oops. I can probably show you that. Yeah. So here is the Max 485 chip, which is the line driver that's actually receiving or sending DMX. And you can see pin 2 here is hooked up through a little grounding, a pull-down resistor to pin 3 of the Max 485, and pin 4, Arduino pin 4, again through a pull-down resistor is attached to pin 2. Those are the pins which control whether the Max 485 is being a transmitter or a receiver. And they're set up in such a way that you can actually just control them with a single control pin. Like if you the transmit portion is active if it's pulled high, and the receive portion is active if it's held low. So in the next draft of this, I'm actually just going to tie them to a single control pin. And then if you pull that high, it's a transmitter. If you pull that low, it's a receiver. For the sake of testing, I did them as two separate pins, just so I had, if I didn't quite understand how something was working, I'd have that flexibility. So in any case, when I go in and I say digital pin 2 output high in my code here, which we'll jump back to, that's what this is about. This is what is going to turn on the transmitting portion of the RS, of the Max 45 chip. So there's that. I am going to preset some Dmx values. I'm going to set them all to 0 to start when this thing turns on. And I'm going to put a little delay in between them. Like I say, when both the servos home at the same time, there is a possibility of browning out the voltage regulator. So that's just going to help avoid that on startup with this thing. Okay, so now we'll write our loop. So this was the code I was using last time, which was just fading all three of them to full over the course of, 3 seconds, and then jumping back to 0 and continuing on from there. But that's not quite what I want to do. And I think actually I'm not sure I'm going to need these dimmer val, channel val things. I think I can write this all in one series of nested for loops. So what we're going to do, so we said we're going to make the pan go from 0 to full and back again, let the tilt go from 0 to full and back again, and let the intensity go from 0 to full and back again. So I'm going to iterate over 3 different less than or equal to 3 I plus plus over 3 different channels, and for each of them I'm going to do the same thing. So I'm going to wrap this all up in one big for loop. Or maybe 2 different for loops. That'll probably be easier. We'll call our inner loop j equals 0. J is less than or equal to 255. J plus plus. And actually, why don't we make, for this, normally if I was writing this, I wouldn't bother giving these descriptive names, but let's give these descriptive names. Instead of calling it I, let's call it parameter. So parameter will be intensity, pan, or tilt, and we'll call this inner loop value. And that maybe will clear up a little bit of what we're doing here. So inside this loop, I'm going to set the channel value for that parameter to the value, and then I'm going to delay by a small amount of time, because I don't want this to happen as fast as it can. In my previous testing, I was using 15 milliseconds. This delay function just delays by a certain number of milliseconds. So delay 15 milliseconds. So, and then outside this loop, I'm going to delay by 400 milliseconds, say not quite half a second. So what this will do is, for first our intensity parameter, we're going to increase our value from 0 to full in a slightly slower step. And then I actually want to do the same thing in reverse. And there is we could find a clever way to make these 2 loops into one, right? A thing that steps up and a thing that steps down and does similar things. That is just a little too clever for my taste. I think it's going to start obscuring what we're actually doing. So now we have a loop that's going to ramp up from 0 to 255, a little bit of a delay. We're going to go from 255 to 0 with a little bit of a delay. Oh no, this is fine. So yes, this is going to ramp Dmx values, and then the slave is what takes care of translating from 255 values from 0 to 255 to pan and tilt being from 0 to 180. I'm going to come in here first 4 lines. Second parameter is a typo. Oh, thank you. Yes, thank you very much. All right, let's do just a quick compile and see where the rest of my typos are. Yes, this is not correct. This is, I did a global find and replace, and this is actually the object name. Got a leftover macro from OBS. Class Dmx set channel. Set channel is wrong. Set channel value is what it is called. This is now an Arduino troubleshooting stream. And I'm actually going to just comment out the rest of this so it's not doing anything we don't want it to. Try again, compiling. Compiles just fine. So hopefully it'll do the thing we want it to do. Should probably, pin mode 2 turns on transmit. That should be all right. I mean, I don't actually need any of those defines because we're just going to do it all in this loop here. So I think this should be okay. So let us, I'm going to upload it to our Arduino master unit that I'm using here. It's flashing away, and we have uploaded. Great. Well, that's a good sign. So let me take you back over to the table now, and we'll see if this actually works. There we go. Let me just double check while I'm still sitting near the computer. Let me see if I turned autofocus back on or not. I did. I think I'm going to turn that back off. I'm so sorry for all of the stream messing around with. Like I say, I'm not much of a streamer. I'm more of a building things kind of a guy. All right, so there's our little transmitter. It's programmed. I'm going to actually leave it plugged into this FTDI converter because that's what's going to give it power for the rest of our experiment here. And to get that hooked up to the little mini moving light that we finished building just a little bit ago, I whipped up yesterday, forgive me, this, which is, it's not as janky as it looks. What it really is it's 2 sets of 3-pin XLR connectors, male and female, and 2 sets of headers. And what this means is I can basically tie any device that has any gender of DMX connector into any gender of DMX connector or to bare wire. So for today, because I may have to take this apart again, I am going to leave these DMX connections as bare wire, and I'm going to just wire them straight into this header here. So this is just the kind of like usefulness tool that I think I'm going to have some further use for in the future as I continue to mess around with these things. Let me just make sure this is as focused as it can be. Yeah, it seems all right. So let's get this thing wired up. See if there's a better spot to put a light there. Got a little glare off this labeling system. All right, so I need my little flat head here, and I'm gonna hook up. And I know what this color code for the DMX corresponds to because I made it. So my gray wire here is going to be my Dmx Ground. And nominally, you can run DMX over just a pair of wires, such as it is a differential signal. The ground is there to sort of take care of any common mode current that would be flowing because of differences in ground potential, or maybe both of your systems are ground referenced, or at the end of the day, or something like that. So I'm just going to sort of obey that little part of the DMX standard, even though I'm not really obeying any others. This is also, so clearly there is no DMX termination in this system. And for something like this, I'm just gonna get away with that sort of crime. DMX is at the end of the day only a 250 kilobaud system or transmission, and over cable lengths of 8 inches. Yes, there will be signal reflection, and yes, there should be a terminator somewhere in here at the very least of the transmitter side. But over that sort of distance, even a relatively medium impedance line driver is going to have no problem getting a signal through to something that's 8 inches away. So in this case, termination is not going to be a huge issue. If I were going to start installing a fleet of these, then yeah, maybe we would start to think about it. The other thing is, if you ever pop open a moving light for maintenance, you'll see that if you have, 2 XLR connectors in and out, sometimes they will be through-wired straight to a circuit board and then back out, but more often, your input connector will be wired directly to your output, and then you'll have like a 6 or 8 or 24-inch jumper of wire going to your PCB. And if that's good enough for, say, Verilight, then that's going to be good enough for a hobbyist. So that's the DMX wired up. I've got, this transmitter is in theory transmitting, which is a good sign. I am going to hook up the DMX there. That's all connected. So really all that remains is to give this thing power and to see what happens. Does anyone want to take a guess as to what's going to happen? Yeah, this is kind of the moment of truth, right? Like, if there's going to be a moment where there's smoke, this is it. So I guess we'll just give it a try and see how we do. I am going to use my variable bench power supply here and just alligator clip onto these leads, which I'm kind of going to bend out of the way. Okay. So, fully admitting my crimes here, like, if I was being a due diligence person, I would have tested this along the way. I would have, assembled the servo and then tested the servo and then assembled the top and I tested the top and test the LED as we go. I'm just going to do it, and it's going to be great, I hope. So that's alligator clipped on there. Hold it a little bit of an angle so hopefully you can see what's going on if that LED does light up. I don't have any expectation of this working the first time, but I'm just going to get on with it. I'm going to turn on power supply there. Let me slowly increase the voltage. Ooh. I can hear that servo stalling. Interesting. So no light, no movement, and the servo is stalling. That servo seems to be locked at 0, which is interesting. It makes me think that maybe I'm not getting Dmx into the system at all, because this servo, the tilt pan servo, is fighting me. It's locked at 0. The tilt servo, it's not making great contact, so it's hard to tell, and the light's not on. So this is probably telling me that my system is not getting Dmx at all, is what I would guess. So I'm going to turn power off and do just a little bit of investigation as to why that might be. Let's zoom out a little bit here. I'm not going to have a great way to show you this, but I'm going to break out the oscilloscope. Derek says current limited. I'm not showing current limiting on the power supply. It could be current throttling at the 5-volt regulator. I'm not sure if you were here. The 78 MO5 that I'm using is a 500 milliamp limit, which I didn't realize when I ordered it. So I could be limiting there. Let's see. What could we do to address that? Why don't we start by, let's set the... I guess I could unplug the servos so they weren't drawing any current and then just run the LED around. That might be a way to go. But first, let's see if we're getting signal into, or Dmx coming through the system in the way that I think it should be. I'm going to turn on the scope here. I wish I had a setup that I could show you what's on the scope as I go. You can maybe kind of see it on this secondary camera here. So this is the thing I warned you about, right? Like, this, if this had been success, like, we would have been like all saying goodnight and drinking champagne and having a grand old time. But for the moment now, it's a troubleshooting stream. Derek says, I definitely wasted time troubleshooting when my bench supply was turned down. Is all. Oh, it's a fair point, Derek, and I have definitely done the same thing. I guess, I mean, it can't hurt. Let me try it again. There's no way you can see those dials, right? No, I wish. But let me just I'll turn this up to about 9 volts, and the ammeter on my power supply here is showing like 40 milliamps, if that, and my current limiting is all the way up. So it's a really good thought, but I'm just not showing limiting. So let's double check Dmx. Yeah, I've got Dmx coming in, and it is the polarity that I want. So one of the nice things about this transmitter outputting 512 addresses and most of them being 0 is it's really easy to tell if the polarity of the Dmx coming in is correct, because if let's see, how can I show you this? All right, I'm gonna switch cameras real quick. I'm gonna do some crimes to these cameras and we'll see what we can show. I was just earlier today thinking about like a magnetic mount for all of this, and I didn't do it, but Yeah, there we go. So if I probe the 2 input points for the DMX here, I've got 1, oh, can you see that pretty well, and 2, or actually pins 2 and 3, which should be, according to spec, that should be negative and positive polarity in the signal, and you can tell they are. So that is the appearance of a DMX signal where almost all of the values are 0. It spends a lot of time at, nominal 0 volts, and then the reverse of that, where they spend most of their time closer to, the positive side of their voltage range. So that's a really quick and dirty way of confirming that, like, the polarity is correct through from my transmitter to my little janky circuit board here and into the light. So it's not that. Let me get this other camera clipped back up. All right, so is that better? Yeah, okay, so that's good. So I guess the next thing I'm going to try is going to pop the cover back off of here and see if when I take the load from the servos off this system, will it just dim? And if it doesn't, then we'll go from there. It's interesting that the servos think that they should be, locked at 0. Like I can feel them locking at 0, and it could be limiting. Like it could be limiting on the 5-volt power supply rail, but I'm not entirely sure. All right, so all I'm gonna do here, let's see, get a little action there, is pop these servo headers out and see if this thing behaves any differently when I turn it on now. I mean, obviously the servos aren't going to limit, but see if it at least dims. No dice. No dimming. Interesting. All right, well, so much for that. Let's go ahead and pop this LED star back out. I mean, it's possible I got the polarity wrong on these. What my labels match their labels, but that doesn't necessarily mean my labels are right. So maybe I will just swap these around, because if I'm wrong, I can't hurt anything. Oh, or maybe I shouldn't turn the voltage up high enough. Maybe I should do that. So like I was just saying earlier in the stream, this LED star is 3 white diodes in series, so it has a forward voltage of like at least 9.5, 10 volts. Well, it was a good thought. So not that. We got a few more things to try. It's going to be great. And, if nothing else, if we just can't get it working tonight, we'll just put it back together and we'll go, ooh, and on. Isn't it like a pretty model of what someday might be a moving light? But I'm not giving up yet. We do have more things we can try here. Because on my last stream just a couple days ago, we did test out the dimming circuit for this, and it worked fine. In fact, with this very PCB. So I know either I've broken something in the meantime, or I've done something wrong in the reassembly of it. So let's try reassembling, resoldering, counter to what my labels would have me do. We'll just assume that my labels are incorrect. The comment from Derek. Worth checking data on the output of the RS-485 transceiver in the light. Yeah, for sure. For sure, yeah, I could stick my probe in there. The trick is, it's a very good idea, except the... Oh, no, I could totally do it. So in this design, the RS-485 transceiver is actually underneath the Pro Mini there, in between the headers. But the data is coming into the RX, digital pin 0 pin on the Arduino. So I could meter right at that pin on top. That's a very good idea. If this doesn't do the trick, and I have my doubts, then that will certainly be a next thing to try. Derek, this is clearly not your first time knocking around the inside of a DMX system. Let's see. All right, so those are resoldered what I think is backward. So if this works, it just means I made a labeling error, and I would actually be delighted, but I sort of have my doubts. So we're still hooked up here. We're going to hook up to power. The transmitter's still plugged in. Let's zoom back out. Let's see. Oh, ooh, did you see that? Oh, yes, labeling problems. Yes, very good. Still doesn't explain why the servo's locked, but this is a very good sign. So, ooh, we're not dimming. We're just on. Interesting. Interesting. Well, the nice thing is if I idle my power supply at like 6 volts, then that LED can't turn on. Because I'm not entirely sure that this star will survive indefinitely with no additional heat sinking as well. So I'm kind of rolling the dice here. The maximum current through these diodes is listed as 1 amp. And the way I have my current limiting set up on the buck converter driver, it actually will max out at half an amp. But even so, you know, half an amp at like a 9-volt voltage drop, you know, we're talking about 4.5 watts total, so like 3 watts of heat coming off the back of this. And that's, you know, for theatrical use, I would normally put a heatsink on that. So I'm not entirely sure. At some point, we may just release the magic smoke. Oh, Derek says, I fix moving lights for a living, so this is not new territory for me. Yeah, I kind of got that feeling. Yeah, I know, right? Light came out of it. That's a good sign. So the driver chip that I'm using, right, is basically a buck converter, and it puts the LEDs in the current path that's of the buck converter, like in the next to the inductor that is part of the buck converter. And the IC takes care of making sure the average current through your load, through your LEDs, is set by a specific value of resistor that you solder between 2 of its control pins. That sets your max current, and then if you apply a PWM signal to one of the other pins, that, you know, reduces from max current down to min depending on your duty cycle, right? So if it's getting DMX input and this thing is PWMing, it should be modulating the output here in you know, corresponding to the DMX signal that's coming in. That's also not happening, which makes me think it's not getting that PWM signal to the driver. So that's something else I could put a scope on. What I really need is another camera pointed at the scope, or a little free flowing camera that I could just wander around with, because I'm not going to be able to I'm not going to be able to hold this camera and probe and show you what's going on. Well, what's going to be more interesting? Me poking at things with the probe or the oscilloscope? I think the oscilloscope is going to be more interesting. So let's do some more camera crime. Gotta remember my soldering iron is still on, and I'm gonna try not to melt any camera wiring while I move stuff around. Let's see if that's gonna stay. Almost. Yeah, that might stay. All right, so if I go back to this, hey, look at that. It's upside down. Other than that, it's pretty good. So let's just let's take a hot second, because I think we're probably going to want to keep doing this. So let me take 2 seconds here and make it so I can come back to this when I need to. Rotate that 180. You can see what's happening. And let's adjust the focus on that too, as long as we're here. Sure, that's as crisp as it can be. There we go. So probably overkill, but now you've got a nice view of an oscilloscope. So that's kind of classy. Ooh, and the top of my head. Amazing. Okay, so let's give you some sense of what's happening here on this. This camera here is I'm glad you can't see what it's strung up by. It's not Tony Award-winning work. Let's say that. Okay, so I was gonna see. So I have my power supply idling at like 5 volts, which means that the LED is not going to turn on, but the Arduino is. And now I'm going to probe around and see if I can figure out if the PWM signal that should be coming out of pin 3 is, or is not. Looks like nothing doing. I'm just going to hold it there for a second, because in theory, the transmitter is still ramping. And when it does, it should dim when the DMX tells it to, but that's not happening either. It's really interesting. So let me probe. Let's see, my data input pin on these Pro Minis is the RX0 pin. Those are not adjacent to the rest of the data pins, of course. So have my handy dandy cheat sheet. All right, so yeah, I've gotten rid of the camera that would show you that, but that's my pin layout on my Arduino Pro Mini, and RX and TX are next to the headers in the top left. Oh, you know what it might be? So way back in the mists of time, turn some power off here. Back at the beginning of this video, I don't know if anyone was here, but I said there is a little physical switch on these devices that turns them from programming mode into receive mode. Because of course, if you had these, the library that I'm using shares, basically obliterates a serial library, overrides a serial library, and uses that to do its, its reception of DMX. And so if you have DMX coming in, you can't also program the Arduino. There's a hard switch that just separates the RS-45 transceiver from the Arduino, and I bet it's still in its programming setting. And yet it totally is. I know you're still looking at an oscilloscope, but if I switch that and I apply a little power, the Arduino turns back on, and now I probe pin R0. Yeah, there's our DMX. Oh, Jeff. Jeff, that's so dumb. Well, let's see. Is there anything else I need to probe? I guess I can probe, since you're still looking at the oscilloscope, let me probe pin D3, which will be my PWM pin. And if everything's gone right, so we should be ramping through pan, tilt, and then the intensity. I don't see that happening. That's also interesting. What's happening if I turn the voltage up? You probably will see it on the small camera. Yeah, I'm still not dimming. So we might do a little workaround code just to see if that's if something else is wrong with the system. But at the very least, the reason it didn't look like DMX was getting into the system is because DMX was not getting into the system. Okay, so that's progress. I'll tell you what, just to verify a little bit more of a system, let me take you back over to the Arduino code for a second here. We'll look at that. While you're over there, just briefly, I'm just going to undo some of my camera crimes in the background here and turn off the scope. All right, so let's roll over to the Arduino code here. Well, I feel good that we got the thing to light. I feel silly about the two errors I've made, the two big errors I've made, right? One was a labeling error, and one was a, remember to flip a switch to on error. Let's see, you're looking at the master. Let me let you take a look at the slave programming, which I'm looking at. Yep. So what I'm going to do at this point, so I'm going to just comment out some of this slave code. And for now, I'm glad to be getting DMX. I am going to do two things. I'm going to write a for loop that just ramps the PWM to that LED up and down to make sure our dimming circuitry is working. And I'm going to do a different thing to test if the DMX is working, but let's do them one at a time. So this again is a real sloppy loop. Less than or equal to 255 I plus plus. We're just going to let's see. That's what I want to do. So from 0 to 255, we're going to write that value in PWM to the LED pin. Derek says you haven't blown anything up yet, so you're doing fine. It's true. No fires tonight so far, which is very good. And then we're going to delay a little bit in that loop. So really, all this other setup, this is not going to have anything to do with DMX. I'm just going to write a ramp and let this thing run. So that should be fine. All right. Let's see how bad my camera crimes are. Ooh, they're not great. Let's refocus. That's better. So let's roll back over here. Ooh, I need to do a little flip for myself. There we go. So I'm going to take my programming cable here. I'm going to take it out of the transmitter. I'm going to hook it up to the slave. And I'm going to just program this in. Oh, and of course, I can see it's not programming because I'm in run mode and I have DMX coming in. So I'm going to unplug the transmitter here. I'm going to try re-uploading. This is, again, there's this conflict between DMX coming in and it trying to program. And actually, once you've done this, it hangs the COM port for a little while. And just easier just to clear it by unplugging that FTDI decoder and plugging it back in. Oh, here, you can see, you probably see top of my head cam again. This is what happens when I lean over my laptop to do more code while I'm programming things. Let's see. It's a little confused. Oh, oh no, it should be fine. Maybe that's holding the line down. I'm just going to move that little tiny switch back to the program setting. And once again, power cycle my FTDI converter. And uploading. Oh, it's very confused. Why is it so confused? Just getting 3 little flashes on my FTDI converter, and it's not uploading. What I might do, just off camera here, is restart my IDE. Because sometimes when it gets confused about whether its COM port is available or not, that does help. All right, here I know this is nothing interesting to look at, but I think it'll be faster for me to boot this back up here, make sure I've got the right COM port, and try uploading. Piling. Uploading. Uploading fails. Okay. Why would that be? Interesting. All right, well, on the chance that there is something in this circuit that's confusing it, I'm just gonna, that's the nice thing about having this built as a shield, is I can just pop this Arduino right out and program it outside of the device and pop it back in, which nominally is what that little switch is supposed to enable me to do, but I'm not quite sure what's going on. So this will be a nice safety method. Oops. Not uploading. Not great. Well, that's all right. That's why we have spares. Literally, new inbox. I think it is possible that because I tried to upload while it was also getting, well, the receive pin was also getting driven by the Max 485 with incoming DMX, that I may have irreparably confused something and burned $1.50's worth of Arduino. Oh no, oh no. All right, so there's that. Brand new Arduino, you can actually still, it's running its little Blink program that they all come pre-programmed with. Let's see if this will program. Yes, that one programs just fine. So probably have borked that other one, and I should just set it out to pasture, but that's all right. So, all right, now that's programmed. Plug this. So this is still in program mode, so that's okay. Power is off, so I can't blow up anything. Now, oh, what a mess. Get some of this out of here. So this time, so remember, this code is just running PWM ramp from 0 to full, from 0 to full, from 0 to full, until it just can't no more. So hopefully we'll verify that the dimming circuit here works. Maybe we'll have to put the scope back on it and make sure that that actually happens. So I'm going to turn on the Arduino. Yes, it is working. So it's ramping from 0 to full. It's interesting, the dynamic range is not extreme. Like visually it seems like it goes from 0 to bright very, very quickly. But that's good. That means the dimming circuitry is working. So that's progress. In fact, here, I'm gonna do that again. I'm going to snap the optic back on because I think we're probably blowing out that camera there. So I'm going to angle it away from the lens a little bit, and hopefully that helps us see a little bit better. I might also just walk over and I'm just going to turn the desk lighting down for just a second so you can see a little better. Hopefully see it starting to ramp. There it is. So that's the low end of that ramp. So that's got a fair amount of dynamic range. The upper end does not. But that's okay. We can live with that, or we can work around it. So dimming circuitry working fine. That's a great sign. So let's turn power off so we don't blow anything up. Let's do this one step at a time. Let me take you back over to the Arduino code. So we've done a ramp on the PWM. That works fine. Let's do a ramp on the PWM. When that's done, we'll shut the LED down. And so I'm going to basically test all the functions of this light in isolation, and then we'll try them again with DMX. Let's see. So write a little loop that takes us from 0 degrees to 180 degrees. Nice and slow. And then we'll just leave. Let's do it nice and slow, and then let's take it back the other way. So there's not a point where it's trying to snap back at full speed. So we'll take it from 180 to 0, decreasing. Okay. So in theory, we should ramp our LED up to full, then turn it off, turn our pan servo from left to right and from right to left. And again, none of this yet on DMX control, because I have verified the DMX control functionality of of this hardware before, so in theory it should work fine. But take you back over here. All right, so let's program that in. Power is off. We're still in our program mode, yes. Click on program. Uploading. Seems to be going fine. So, all right, so that's programmed. Oh, and I'm gonna have to plug the pan servo back in order for us to see if it does anything. I'm also gonna have to turn power onto it, I suppose. That's perfectly reasonable. So pan servo goes into the little pan servo header down on the board there. So pan. All right, and then I'm gonna turn on power. Ooh. Hey, there it is. Left to right, right to left. Oh, I got it backwards. That's all right. And then it just sits there. Left to right. Hey, isn't that something? Okay, good, good progress. And then if I turn the voltage back up, we should see the first part of that ramp where the LED ramps from low to high. Yep, there it is, getting brighter and brighter and brighter. A little weird flicker, which is interesting. And it feels like, I might be crazy, that flicker to me, so there's a little bit of chatter noise coming from the servo, and the flicker seems to be at the same frequency. I'm also not running these LEDs at their forward voltage, because I'm trying to minimize the amount of heat, although the heatsink isn't even getting hot. Let's just kick this up a little bit. Now, ironically, the higher voltage than I have my power supply at up here on the bench, the harder the 7805 has to work to provide 5 volts for the servo, but the less current flows through the flows through the buck regulator, basically, because it's just doing current averaging. Ooh, I could feel the heat on that one. Ooh, let's kill that for a little bit. Yeah, now we're getting to that point where I said, I said I wasn't sure if I was going to need a heatsink on this. Well, I think I may have established that. But again, onward and upward. All right, just for one final test, I'm gonna take that same program, which thinks it's still panning back and forth. I'm going to just plug the tilt servo into the pan output, and see if that tilts like it should. Tilt servo, pan output. And, well, just for the sake of testing, so I have this old heatsink that I got from a Hamfest, that I've been using for testing purposes. I'm just going to stick the LED right back on that for now, just for safety. Just because, like, again, it's a clearance LED. I don't really mind if I blow it up, but I kind of mind if I blow it up tonight, just because we're having a good time here. So I'm actually going to reach up into my bin O adhesives and grab my heatsink compound and just stick that back down real quick. So this is just regular old like CPU heatsink compound. Just a little blop there. This is so overkill, but again, like if we did blow this up right now, right, we're in the thick of things, things would kind of come to a screeching halt. And that would be a shame. Okay, so recap. Arduino running a loop, ramping the LED from 0 to full, then turning it off, then running the tilt motor from 0 to 180 and back again. And we're going to see what happens. Pan did fine in isolation. Let's see how tilt does. Let's see. I'm just going to prop heatsink up so the lens on the front of this LED is not shining directly into the camera. I think that will help you see what's going on. It's like a 15-degree optic for this particular LED star coming off the front there. So I'm going to turn the voltage on my power supply. That's 5 volts. Oop. Yeah, there you go. Can you see it tilting? Yes, so what's happening is, all right, I'm going to turn the voltage up and just make sure that the LED is still doing its thing when it thinks it is, but Yeah, so that LED is still dimming, so that's good. I had the voltage set a little bit low. And we're still panning there. So, yeah, let me show you what the problem is here. And it's mechanical, so I'm not 100% sure we're going to be able to fix it tonight. But, let me zoom in a little bit here. So, this is the attachment point between the pan servo and, here, let me get a little bit of fill. You can see what's going on. Yeah, so the tilt servo is just mounted inside the body here. It's connected right through the yoke to this little screw, and that screw is meant to make firm contact with the little inset in this yoke here. But when it's panning around, I can hear basically the teeth on that pan servo slipping on the inside fitting of this yoke, which means it's not actually panning as far as I could. In fact, I can, like, if I do this, I should only be able to do this if I'm actually rotating the gears of the servo, and it's just slipping in there. So that, unfortunately, is a mechanical problem. And if I don't have a fast way to attach the inside of that yoke to the top of that sort of servo button there, then this may not be a thing I can solve without reprinting that bit of the yoke. Which would be easy, right? That's maybe like a 15-minute print, but I don't know if that's something we want to take the time to do at the moment, because we can still get a pretty good demo. The tilt's just going to be a little janky. Maybe so. We started this stream back when I was a young man, looking through the 3D print design for this part and a little bit of the circuit design. Maybe after we reassemble this and test it one more time in a second, maybe we'll end things off by going back and looking at the 3D print design and the circuit design, and we'll just sort of walk through all the things we discovered tonight that we need to fix for the next time we take a swing at this. But the tilt is working. It's just there's a mechanical problem, like where that servo interfaces with the yoke. But that's all right. Let's do one more version of this just to make sure I'm not crazy. I'm going to plug the tilt servo back into tilt. I'm going to plug the pan servo back into pan. I'm going to write one more little bit of code that's going to, ramp all three of them in turn, just to make sure there's not some kind of weird crosstalk, and then we'll go back to our DMX-controlled version of all of this. All right, so those are plugged in where they're supposed to be. Power is off. Let's go back over to the Arduino Code, and we'll write just a little bit more. Sir, go. So this last little bit of code will basically be the same as the previous bit, except instead of the pan servo, which goes from 0 to 180 and 180 to 0, this is going to be the tilt servo. We'll go from 0 to 180, and the tilt servo will go from 180 to 0. Derek says, "Gotta run. Good luck with the light." Thanks, Derek. Hey, and thanks for the advice. And I hope your moving lights are just like a little bit bigger and a little bit better behaved. And I'll catch you next time. Thanks, man. All right, so that's our slave test code. So I'm going to plug this in just briefly and upload. All right, so that's uploaded. Unplug the coder there. And we will, let's switch back over to our tabletop view. And we'll turn on a little bit of power, and we'll try this again. Oops. Zoom out just a little bit there. What have you got? Oh, camera cable. All right, so, and again, this is not yet DMX controlled, although we did verify that the device was getting DMX all the way into it, which is good. This is just going to be a test to run. The LED should ramp from 0 to full and then turn off. The pan should go from 0 to 180 and back. The tilt should go from 0 to 180 and back, although of course we know that's going to slip a little bit. So that's the dream. I'm going to turn on I'm going to reapply this heatsink to this LED, just for good luck. And what's going to help us see that a little bit better? I'm just worried that we're basically just blowing out that LED there. It's also just catching the light in a crazy way. Maybe if we shadow it from the work light on the table with my soldering fan, maybe that'll help us see it a little bit better. So let's give this thing power. I'm going to start by giving it 5 volts so we just see the servos at work, and then we'll turn on the LED as well. Because again, the servos run at 5 volts off of this little 5-volt regulator down in here, and the LED won't turn on until its forward voltage, until the voltage of the incoming power supply down here is at least the forward voltage of 3 white diodes in series. All right, we still got a good view of that. Let's turn this puppy on. There we go. So panning, tilting, and slipping, which we knew. Yep. And dimming. Yeah, that's me turning up the, whew, we're getting right into that camera. All right, so pretty successful, you know, a couple mechanical issues, and a couple of other little PCB issues, but pretty good so far. So what I think we're gonna do, now that we know everything basically works, is see if we can get it to do this same thing, but under DMX control. So I'm going to take the slave code, right? Because that was all just running on the slave. Had nothing to do with the little mini transmitter. That's just the slave doing its own thing. I'm going to take that slave code and basically put it all over into the transmitter. So instead of running a ramp internally, we're going to run a DMX ramp on all 4 of those parameters, 3 of those parameters, I guess. And turn the slave back into just listening to DMX and see if we can figure out what's going on there. So let's head back over to the Arduino code. And I'm going to take just a second to make it easier to go back and forth, because we're going to have to go back and forth between the slave code and the master code a little bit here. And it will just be easier if I can switch back and forth a little bit faster. So I am going to, I'll tell you what, I'll take you back over to the tabletop view, so at least there's something pretty to look at, and you don't even see the top of my head in this camera, which is nice. I'm just gonna set up one more scene here, and we'll set up. Like I said a couple times in the stream now, I'm like 95% a making things guy and 5% a doing things on video guy. So I am, this is my, it's all new to me. So I'm having a real good time, but if I seems like I'm making things up, then that's exactly what's happening. Okay, so let's see if that does the business. Oh, of course it did, but I have to change what window we're actually looking at. So instead of slave test, oops. Well, that's all right. We can, if this doesn't work in the next 20 seconds, we'll just move along. We can just do this manually. Oops. Okay. So just a little behind the scenes peek. So OBS, which is what I'm using to stream, is no longer seeing the Arduino IDE, which is a shame. So I'm just going to restart the IDE because it likes to see windows that have opened since you started the program. So I'm going to open up my code one more time. And open up this. All right, we still got this camera. We've still got this camera. We've got the Arduino slave. Let's see if you will show me the master code. Yes. Master test. Yes, great. And if I go over here. All right, so what we really need is a need to make these two things different. I'm so sorry. This was going to be a DMXy stream, and now it's a stream about streaming. There we go. Master, slave, master, slave. All right. Well, notes for the future. Now I can set that up ahead of time next time, and we won't have to mess around with it on stream. Okay, so we were going to write some code. So let's look at the slave. Oops. Let's look at the slave. Yeah. And we'll look at the slave on my screen too, so I can follow along. So right now, that was just running its own little loop, right? It's running ramp, 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 ramp. So I am going to take all of that. I'm just going to copy it out. I'm going to comment it out in case I want to come back to this step. And I'm going to uncomment these 3 lines, which for those who were here earlier, basically the Dmx channel, Dmx address 1 will control the intensity, Dmx address 2 will control the pan, Dmx address 3 will control the tilt. Easy enough. Now let's go back over to the master, and you can come to, right? You can come to. Oh, no, you gotta come to over here. Yeah, there you go. Look at the master code. And the master code, which was running its own kind of loop, we are going to blow that away. Let's start from scratch. So now, instead of doing analog writes to the pins, what I'm going to do is set the DMX channels to the same values that we would have been looping over. So the goal here is that this time through, the actual physical devices should be doing exactly the same thing, except that they'll be controlled by DMX instead of doing it locally. So set channel value 1 to I. So that'll be our first channel. That'll be our LED. We'll ramp from 0 to full. And then we're going to snap it to 0. Then our pan value, which is our second DMX channel, will ramp from 0 to full. And this is just test code, so I apologize that it's not commented, it's not really clear, it's all sort of, manual, but for the sake of testing, I think it will come across what we're actually trying to achieve here. Okay, so let's just make sure that compiles. Forgot a semicolon, let's make sure that compiles. Forgot a semicolon, let's make sure that compiles. It compiles great. First time, let's take a look at the slave code. Just make sure that this compiles. There's probably a missing semicolon here too. Oh no, first try. Well, that's great. All right, well, let me take us back over the table. We'll do before we turn the power back on, we'll do a quick program on both of these devices and make sure they have the code that we want. All right, so this is going to be our slave. Which, of course, the Servo is trying to run off the 5-volt line that's being provided by that FTDI breakout board, which, that's just what it is. All right, so that slave is updated, and it snaps to 0 pan, 0 tilt there because it doesn't think it has DMX, which it doesn't. So that's good. I'm going to plug in my tiny transmitter here, and I'm going to give it its new master ramp code. Try uploading that. That seems to be going fine. You can see the little flashy lights down here, which are it communicating with that device. So that's good. Unplug that. Actually, I'll have to leave this plugged in because this is just getting power from the FTDI breakout at this point. But that is in enabled mode, which is good. Yes, that's a good sign. So let us, top of head cam again. Let us plug these things into each other and see how we do. Let me zoom you back out just a little bit here. So I hope we don't have to go back to scope cam. That took quite a while to set up. But order of operations, I'm going to give this thing DMX for my transmitter. I'm going to turn on the power. I'm going to see what happens. I'm not entirely convinced that anything good's going to happen, but I'll give it a try. All right, DMX is attached. And for those who weren't here earlier, this monstrosity lying in the middle, this is just male and female 3-pin XLR connectors, a couple of headers, all of the ground and positive and negative DMX nets, or positive polarity and negative polarity DMX nets are joined, so I can I can plug in whatever gender of DMX connector I want, and I have 2 sets of bare wire headers, which just makes it really easy for testing to plug in something bare wire rather than having to solder and unsolder an XLR connector when I take this thing apart. So then as DMX, I've got 2 wires coming in down here. Let me just stick this back to its heat sink one more time, and we'll give this a try. Expose. Turn on power. I start with 5 volts. Right, so the Arduino will turn on. Interesting. Interesting. Literally nothing is happening, which is, suffice to say, not exactly the result we were hoping for. The servos are being driven to 0. Which is interesting. But it's as if we're not getting... It's as if we're not getting DMX. Which is a problem. Let's write one more little bit of test code to validate this. Take us back over to Arduinosville. So I'm going to reinstantiate a bit of test code that I was using right at the beginning to test this. So once again, I'm going to comment out our Dmx reception line, and I am just going to say if channel value 1 is greater than 127, digital write 13 high. Else digital write 13 low. So pin 13 on the Arduino right has the built-in LED. So this is just a real easy way of saying if DMX are just 1, if we're getting DMX and its value rises above half on the first channel, turn that LED on. If not, turn that LED off. So this will be, I'm going to leave. What am I going to leave in here? I guess I'm going to leave everything else. Well, here, I'm going to comment to that first. If this works now and doesn't work when I start writing the servos, I am starting to be afraid that there's some kind of a conflict between the servo library and the DMX library that I'm using. It'd be a real shame. And there's not a conflict between the generic serial library and the servo library, right? And I know that this Dmx library, which is the Conceptonetics Dmx library, I know that those 2 things don't coexist well, right? The Dmx library and serial. Perhaps there are other conflicts that I'm not aware of, and that may be causing this issue. And if that's true, we're going to be just a little bit dead in the water because the servo pins are hardwired into specific places in the Arduino by this shield. So there is some bodging we could do to get this thing working, but at the end of the day, I don't know that'll be worth it. But let's not get ahead of ourselves. Let us just oh, Jeff, hang on. I need a sign. That reminds me. As I've now stumbled upon twice in this stream, there is a switch on this shield which toggles back and forth between programming mode and DMX enabled mode. I bet we are in programming mode. Yep. And in programming mode, let me take you with me so you can see what's going on. Ear come with, yeah. So in programming mode, the DMX is literally disconnected from the RS-485 driver. There's no way for it to receive DMX in that state, and it was exactly in programming mode, which would explain why it thought the DMX value was at 0. All right, now we're enabled. I need like a big sign. I need like a big giant sign that says, "Are you in enabled mode?" Well, I feel double dumb now, but at least that's an easy solution. And the transmitter, which has the same switch, right? Because ultimately these are the same, basically the same device, but this one has headers for servos and an LED dimming circuit on it. They're both enabled. I'm going to power this one up. So that's the transmitter. I'm going to power up run that to like 10 volts. There we go, it's trying to tilt. Yep, and dimming. Pretty good. Hey, there it is. Okay, so another moment of panic caused by that stupid program enable switch. I might have to try and find a way around that at some point, but for the time being, I have pan, I have tilt, I have dimming, and they're all happening on DMX control. So that's huge. That's huge. That's like the whole thing we came here to do. Okay, so I'm going to unpower everything. I'm going to reassemble the light. I'm going to plug it all back together, and we'll just see if it all works. If this works, that would be tremendously satisfying, because like I say, that was the whole point of the ding-dang thing that we came here to do. All right, so I'm just going to see, because I can, and I'm a little worried about heat, I have a little pack of, they're meant to be heat sinks for your Raspberry Pi, I think 0W, or maybe just for any of them. I'm just going to see, with the adhesive backing still on, if I can squeeze one of them into this case as designed. Like I said earlier, I haven't designed for a heatsink into this, but if I can squeeze one in, you know, just for the sake of testing tonight, I would feel a lot safer about it. Let's move a few things out of the way. So I could do, I'm gonna get gloop all over my fingers. Could almost do, what I really should do is just stretch this out by another like 5 millimeters. But that'll be okay. For the sake of a brief test tonight, get rid of that heatsink. Gonna wipe a little bit of the gloop off of this. Just for the sake of my hands. Okay, where do we start reassembling this thing? I think we start by, I'm gonna unwire it from DMX for a hot second. And if I forget to plug it back into DMX, someone can yell at me. All right, so that's our connectors there. I need my 1mm Allen head screwdriver. Pan and tilt are plugged in where they're supposed to be. The pan, or the tilt, and the LED wire come out through that little hole. Oops, sorry, come out through a little hole in the case there. The pan wiring gets bundled back up in here. Probably what I should do is finally get myself a proper DuPont connector crimper, and then I could shorten these wires and re-terminate them so there'd be less to cram. Make sure those wires come out. Oops, sorry again. There you go. Where they supposed to. And I think through multiple redoings of this, I'm pretty sure I have stripped out. Oh, this goes the other way. I've stripped out my my screw heads here a little bit because I got a little overexcited earlier. So this may not want to stay. But if I have to hold the whole darn thing together with gaff tape, I am going to get it all working tonight. Yeah, this is not spinning at all. How about you? It could also be that the tolerances on these like no-name cheapy 2mm M2 screws are just not what they should be. So that's all right. I paid like $0 and no cents for them. So that's all right. Yeah, again, this would be great to like shorten the tail on this ultimately, so this is a little bit cleaner, and then I'll do one of those like braided nylon sleeves that attaches the base to the body here. So we'll tuck that LED star with its optic, just tuck it in there, and we'll attach the body back together with its oh so official gaff tape. All right, so that's all tied back together. We are in enabled mode. I haven't changed that. I'm going to wire it back up to DMX. Going to move our heat sinks out of the way. Zoom me out a little bit. Gray for ground. Yellow for negative polarity, minus polarity, whatever you want to, inverted, I guess. Inverted polarity. And orange is positive polarity here. All right, so that's all wired back up again. So now it's time for the test, right? This was all working a moment ago before I put it together. Hopefully it will still work after I put it together. So just to recap one more time, Arduino, Pro Mini Shield acting as a DMX transmitter, going through this monstrosity of a wiring adapter, going in here, taking DMX, Arduino's receiving it, doing LED dimming, pan servo, tilt servo. Tilt servo will slip a little bit, LED's a little bit flickery. These are all solvable issues. Let's give it a shot. Here, let's do... Come on. Get this nice and full screen. All right, so plugging that in means we should have DMX flowing. Turning this on means we should get things powered. I was trying to think what the best angle is for us to appreciate this, either working or not working. I think it's going to be, oops, that's me. It's going to be something like, I don't know. I'm making it all up. It's a little tiny and light thing. Maybe I'll just hold it, and then you can sort of see it in motion. Hold it like so. That seems plausible. Well, this is either the final test, and if it is, we'll go ahead and we'll look at a couple of design changes we want to make in the schematic and go home. Or it doesn't work again, and maybe we'll look at schematic changes and design changes, and then we'll go home. How's that sound? If it does work, maybe we'll look at it in the dark. Maybe it'll look right there. Here we go. I'm going to turn on power supply. There's 5 volts. Yeah. There's pan. Tilt, of course, is still slipping. Help it along a little bit, but it is tilting on its own. And there's dimming. Awesome. And that is, in truth, a DMX controlled moving light. It's not a perfect one. It doesn't pan great. You know, tilt's not calibrated yet. Like, we have some issues to solve. But that is a real honest to goodness DMX moving light. I'm so happy. I'm so happy we even got to this point. You know, this is what I'm calling this version 0.3 of this DMX Receive project. But to get here to mostly functional by version 3, version 0.3 is pretty good. Yeah, that's awesome. So total dimensions on this guy. Let's do this in inches, just assuming we're doing this in freedom units. 1 3/4 by 1 3/4 across the base. Total height. I can just pick it all up. Total height is about just under 4.5 inches with the head down. Probably head up, it's 5 inches. So, you know, fits inside of a 2-inch by 2-inch by 5-inch prism. So that's pretty cool. That's pretty cool. I'm pretty stoked. Yeah, I'm gonna call that a success for tonight. Let's as I promised, we'll go over and look at the design and the improvements we want to make one more time while we go. But maybe we can do it in a way that lets us appreciate our handiwork this evening while we do it. So let's we'll look at our couple of mechanical issues that we had, and we'll look at our circuit issues, and then I will bid you all a good night or a good morning. Let's take ourselves back over to Fusion here. And let me, real quick, I think I can do this in a not awful way. Probably seeing all these changes happen live, which isn't, you know, again, I'm not claiming to be a stream person. I'm just claiming to have a good time. We can just enjoy our little moving light running around in the corner there while we talk. All right, so this is this is where we started the evening, and we're going to end it here too. So this is the fusion model, right, of how this thing came together. And again, a couple errors in the fusion model. So things we want to change. I want to make this hole, which is where those LED wires come out of, a little bit bigger. I need to make myself a cheat sheet of order of operations, so I make sure I get all the wires coming out of the right place at the right time. I want to punch a new hole in here because, of course, that is where the enable and disable switch is. It's represented by this little red rectangle here. So I can actually stick a screwdriver in there and enable and disable it without kind of going in under the Arduino here. Obviously, the fusion model is a little bit janky at the moment, but this printed out just fine. So to create the fusion model there, I need to figure out what the actual tolerancing is on this interface between the yoke and the body of the light here. So to make sure I have a really good contact between that servo part. Here, I can close this off. Between this like inner teeth of this servo and the yoke, because that's what's going to give us all of our tilt action. And then I want to take this actual shell and lengthen it out so I have room in here for a heat sink. It looks like there's room, but of course now I have that optic that sits in front that's taking up most of the rest of the room in the front here. And then I got to think about how to hang it. Like way back at the beginning of this, I put two little M3, embedded nuts on the bottom there for some, 1-inch box truss. I got to think about what that hang hardware would actually look like now, because I could make another one of these and have it dance around. So those essentially are the changes. If I go back, So those are the design changes I would make, and then if we go to our circuit here, and we'll bring our little moving light back into the corner there and let it do its thing. I'm just so proud of it. It's just doing so well. And I haven't blown up the LEDs yet, which is also very comforting. If we look at the schematic here, so again, a couple of things I would change. One is, obviously, you can see it's even telling me the pads for the pan and tilt servos are touching each other, which is not great. I'm going to replace this 5-volt regulator with something a little bit stronger. And next time I would populate, of course, this capacitor ahead of time. And actually, so this is the thing I caught before and haven't talked about. So the maximum current through the LED star in this thing is 1 amp. The maximum current that I chose through for the inductor that I've chosen, this SMD inductor, which of course is in series with the LEDs here, right? It comes out of this output pin, goes through the inductor, and goes through this. This is a 1/2 amp capable inductor. So in the next spin of this PCB, I will either choose a new inductor or more likely just put 2 of these in parallel and hope. 2 of these in series and hope. And I don't know if I'm going to run into resonance issues between the 2 of them. I don't know how tight their tolerances are, but I'll look that up and see how we do. And then this Schottky diode that I chose is actually, I want this thing to be able to run up to 24 volts just for, maximum utility. And the one I ordered is a 20-volt max, so like that's a little sourcing thing to correct. And then as we talked about so long ago, these 2 control pins, which control whether the MAX 485 is a transmitter or receiver, actually only needs to be 1 control pin. So that would save me not only 1 component and simplify some of this like 5-volt routing here. I just don't need that flexibility anymore. I did for the testing, and that was great to have, but now I can sort of let it go. And then maybe I'll rationalize these mounting holes a little bit. They're kind of in this position from a previous iteration of this project. But I could probably make those a little bit more sane. But beyond that, I think this is a resounding success. And for as bright as this is only running at 500 milliamps of the 1 amp that it's rated to go at. So it's hard to tell, of course, on camera how bright this actually is. But it's pretty darn bright. At 1 amp, the rated lumens output is equivalent to a 75 watt Birdie, which is what I'm thinking of this as, sort of a functional replacement for. It's, in the 800 to 900 lumens range. So that's not nothing. It will require a heatsink for sure to get up that high with a continuous duty cycle, and I'll have to build that into the design. But for the time being, I'm really, really, really pleased with with how this has turned out. So with that, I think I'm gonna call this a night. Thank you everyone so much for coming and hanging out. Those of you who've been here for the long haul, and those of you who popped in and out. Maureen Larry says, so cute. Hi, Mom. My mom's here. Hi, Mom. Thank you, Mom. Yeah, I'm so pleased. 2.5 hours from not working to working is pretty good. Yeah, this is a tremendous success. If you want to see more on the background of the previous iterations of this project, including what I'm using as a transmitter here, you can check it out at the address on screen, jeff.glass/blog. Jeff.glass is my website. You can find me on Twitter at JeffERSGlass. That's all the places I am, really. Yeah, I think next steps will include, some of the things we talked about, doing a little bit of physical and programming adjustment. And then I think there's actually, these are both super cool projects, though this one is more flashy. But this, is a really simple DMX transmitter. So I think at some point, whacking a couple potentiometers onto this and turning this into like a real rudimentary light board or test system is probably the way that project will go. Yeah. I honestly can't believe we got this far. I was half expecting for something to go up in smoke about an hour ago, and then we would have been just done. But we made it. We did great. Thank you for joining me on the journey, and I will see you all next time.